All right, everybody. Welcome. Thank you for coming. My name is David MEZA. I am the Chief Knowledge Architect at NASA. By way, really, what that is I developed a technological architecture for trying to convert our data into knowledge. Bottom line is I get to play with a lot of cool toys, a lot of cool tools, and just play around and try to figure out the best way of doing things. Today, what I want to talk to you a little bit about knowledge architecture and how I utilize that to graph some of our special repositories we have at NASA. Right now, some of you probably guys thinking, what the heck is knowledge architecture, and why am I sitting in this room? Hopefully, after I finish this conversation with you guys, you'll be able to see why I think knowledge architecture is important to you, but you'll have a framework for taking it back to your organizations for you to be able to talk to your managers, talk to your investors, talk to your funders, whoever is responsible for allowing you to utilize graph technology and showing them how you can implement this within your organization. So I'm going to give you a little idea of what I've done and how I've tried to implement this across the agency at NASA. Here's some of the obligatory slides. Again, what I'm trying to do with knowledge architecture is basically combine three different disciplines: knowledge management, informatics, and data science. And as I walk through my presentation today, I'll show you how I use each of those within my step-by-step process of trying to extract knowledge out of a lessons learned database. So we're going to talk about challenges. Primarily challenges that I have at NASA, but I'm sure they relate to just about any organization out there. Again, knowledge architecture, how I grafted, and hopefully at the end of this we'll have a little bit of time for questions. But let's start off with a really big, important piece that I've always seen here. Back in 1999, Peter Drucker once said, the most important contribution management needs to make in the 21st century is to increase the productivity of knowledge work and the knowledge worker. That was back in 1999. Since then, what has happened? Social media has exploded. Internet of Things has just taken off. We're getting more and more and more data constantly. And you've seen these in all these different talks of how much data is coming in. So it's even more important today than Peter Drucker said in 1999 that we need to increase the productivity of our knowledge worker. How do we do that? Well, let's first talk about some challenges that we have. You guys may have the same type of challenges in your organization, but in NASA, well over 50-year organization. We have 10 centers. Eight different facilities. So all in all, we probably have about 18 to 20 different locations, 80,000 employees, and we've been creating data since back early, late 1950s, early 1960s. So we've got a lot of information out there, and the data is growing by all those V's that you hear. I mean, I think when it first started big data, there were 3 V's. Now they're up to 6, 7, 8, 10 V's. It just constantly keeps growing with the number of V's that they're adding to big data. But really, our biggest problem is the accessibility to this information. We heard Emil talk about this earlier this morning about the silos. We have silos all over the place, not only just within departments or what we call directorates, but also with individual groups, individual projects, individual programs. They don't want to share information. I've got to try to break down those silos, and graph databases gives me that capability to be able to break through those silos. So in a nutshell, here's my definition of knowledge architecture and how I think you ought to be able to use this within your organization. Knowledge architecture, again, is a combination of knowledge management for strategy, informatics, which is the pipeline to allow you to create those storage capabilities, those applications to actually transmit that data from wherever you're storing it to your end users, and data science. Data science are the algorithms, the methodologies that allow you to convert that data into actionable knowledge for your end users. I'll show you how we utilize that as we go forward. And as you put all those three things together in big data, you're going to come out with what I call data-driven visualization. Allow your visualizations to be done by your data, not the other way around. Don't try to fit your data into a visualization. Let your data drive how you want to visualize the information. Okay? This is my obligatory chart for a bunch of words that management likes to see so they can have something they can spout out later on. So I'll let you guys read that. Well, I'll tell you a quick story of why I started knowledge architecture at Johnson Space Center and then eventually towards NASA. When I first started in the organization about 5 years ago, they asked me to come in and lead to take a look at how knowledge management and with my IT background to figure out how we can expand upon the things we're doing within knowledge management. One of the first things I do is always sit down and talk to the individuals there, go to their meetings, try to listen to them, try to see what's going on. So one of the meetings I was in was between my taxonomist and my IT developer. We were looking at how we were trying to improve search. through taxonomy, through the rule basis, and they were having this conversation, which later on I found out was a conversation they've had many, many times. Taxonomists basically said, I need to look at the metadata. The developer going, why do you need to look at the metadata? So they went back and forth. Well, metadata helps me look at my taxonomy. It helps me to classify. Developer, really stingy with his information. He goes, well, we've got the metadata stored. You don't need to worry about it. I let this conversation go on that day, and I went back later on and talked to each of them as to what they were talking about, because the definition of metadata, data on the data, and everybody kind of agrees on that, but what they were talking about were two different things. The taxonomist was talking about the metadata of the documents, the title, who created it, when was it created. The developer was talking about the metadata on the database itself, the structure. Was it a binary? Was it a blob? Was it a time? All the different types of metadata that an IT developer would. They were talking the same language, but totally missing each other. Knowledge architecture, to me, is a group of individuals within an organization that can help be the liaison between those different types of things. So being able to talk knowledge management for strategy, informatics with the pipeline, the architecture, and data science all together allows your organizations to be able to talk the same language across the organizations and be able to share that information as we go forward. So why is this all important? Well, here you got Eric Schmidt of Google, who said, we have an opportunity for everyone in the world to have access to all the world's information. There's never been possible. Ubiquitous information, so profound, it's a tremendous equalizer. Information is power. I'm going to play semantics a little bit here, and I'm going to say information is not the power, it's the knowledge that's the power. Yes, you can say it's both the same thing, but you can have all the information in the world, but if you can't convert that into actionable knowledge, then you really don't have anything. So we really need to look at how we use that power. And why do we need to look at that? It's because with every great power comes great responsibility. Just like Spider-Man said, when you're looking through all of these things, you've got to make sure that you use that power to be able to transport that information into actionable knowledge to your end users and give them something they can actually work for to be able to come back. Because if you build applications that are not useful to your end users, they're going to die and they're not going to be able to be used. So, time for me to tell you a little story, kind of rev you up and let you kind of give you an understanding as to why I built this application for my engineers. So I had an engineer come to me. He's a young engineer, and one of the first things they're taught is to go to the lessons learned database. In the lessons learned database, you're supposed to have information about all different past projects, what happened during those projects, what are some of the lessons they learned and how they acted upon them and what they were able to do with those in order to hopefully this new engineer, this new project, to happen a lot faster. We're supposed to be able to cut down our project time because we've done this before. So he had 23 key terms that he wanted to search. So he went to our standard search appliance, which is we were using at that time a very famous page ranking system, to look for these different key terms, and they were indexing 20 million documents. So it was 20 million documents, of which the lesson learned database was probably maybe less than 1% of those 20 million. So because of that, he went through list and list and list of information trying to find it. It was going to take him forever. So then he came to me and asked me, what can I do? Well, let me see if I can get them just to index the lessons learned database and then run your key terms against that. So I had the IT department do that. A couple days later, they came back with an Excel spreadsheet, 23 tabs, one for each keyword, with a list of different links that the engineer had to go to in order to look at those just to see if that information was valuable to him. Again, thousands and thousands of different documents he had to look at. There has to be a better way. So I went to go look at our lessons learned database. Now this database here is our lessons learned, LLISDB, Lessons Learned Information System. This is our public website. I can't share with you our private lessons learned database. It's one of those sensitive type of things, what they say. I could show you, but then I'd have to, what? So anyway, but this is our public database. And there's about 2,000, and I use this as a test case to show the technology, how we're able to use this. So and this database is very similar to what we have on site. You can only filter by date, by center, and maybe some other information. But what it did have was some good, excellent metadata within those lessons. So I was able to export this into a CSV file, which I would later import into Neo4j. Okay. So I'll show you that in a little bit how I did that. But while this is useful and helpful, it's very time-consuming. You've got to constantly search. We needed a better way for our end users to be able to see this information. So what did I do? I started looking at how am I going to take my little document and convert it into a graph. Now, currently, I've kind of gone to the second, third iteration of this, and I'm now using a MongoDB database to hold the lessons learned, automatically create that into a graph database through that connector. But when I originally did this type of work, I did it straight from a CSV file with all the metadata and created it into a document database. And of course, once you do that, you start seeing patterns. Patterns emerge. People can walk through this a little easier. And our brains work a lot better that way, able to quickly see where the patterns are evolving. This is actually a representation of our ontology that I put on GetP, primarily just to show you that patterns can develop pretty quickly, and you can actually show through that. So what did I do? So let me backtrack a little bit here. So what do I have? I have a lessons learned database. The lessons learned database is part of the knowledge management strategy. You go talk to your knowledge management professionals. That's one of the strategies of how you collect, store, and share information. Part of your storytelling, part of being able to get that information. So that's step one, the knowledge management strategy. The application that we're going to talk about is going to be the informatics part. But before that, I have to throw a little data science on top of that. So I have the lessons. I took all the text out of the lessons themselves and ran them through a topic modeling algorithm, latent Dirichlet allocation, giving me in this case, I believe it was 27 topics that came out of this scenario. So now I have an additional piece of metadata that I can add back to the lessons, the topic. On top of that, because there was a lot of metadata already with these type of lessons, I was able to correlate the topics based on their self-assigned categories. So now, not only do I have the lessons there when they're topic, I also have the correlations between the topics so that I can easily see how one topic may relate to another. And I'll show you some examples of that in a little bit. So once I do that, here's the correlation by the categories. I'm able to showcase different topics and how they're correlated and run through that and add, again, another metadata that I can throw back onto the lessons learned database and add that to the columns. But one of the things you can do with something like this is look at trends. Trends are very, very important, especially for an organization such as us that we kind of have to, we've been around for such a long time, and hopefully we're going to be around a lot longer, and we have to really be really careful because mistakes that we make can affect people, can actually kill somebody. So we have to be real careful, and unfortunately it's happened to us, and we have to learn from those mistakes as we go forward. So if you take a look at using some of the theta probabilities on these topics, you can look at some of the trends. These are the cold topics, things that have actually gone lower over the years. But I wanted to point out this one right here, topic 14, talking about material, thermal, excess, contamination, temperature. Really, all of that's talking about the tiles, the heat thermal tiles underneath the shuttle. So we had some lessons that were in there that started right here, and that's right about 1990, and they kind of went up a little bit, down. They kind of went up and down up until around 2003, when we had that unfortunate disaster when we lost one of the shuttles because of the tiles. If we would have had this information beforehand and understood the trends that were happening, we may have, not saying that we could have, but we might have been able to pick up on this a little bit sooner to understand that other people were also seeing the same issues, that we needed to really look into this. So those are some of the power that you get from applying data science back onto your unstructured data to be able to see through something through that. Oh. And of course, the other thing you could do is just from a visualization standpoint is to take a look at the topics themselves. If some of you guys are familiar with R, this is a package in R called LDA Viz, Latent Dirichlet Allocation Visualization. The package here, all you do is you apply your data frame back to this. It's able to show you all the different topics you've generated and the terms that are in the topic, and it's interactive. As you highlight over a topic, it'll show you those different keywords that are, or key terms that are associated with that topic. Something good for an analyst to do, something good for them to be able to look at, to try to figure out what's in there, but not really good for my end users. So I had to do a little bit something more for my end users. So the first thing I needed to do, of course, is start figuring out how do I model this to be able to showcase it for my end users. It's a very simple model here. Because I'm talking about a very specific repository, and I focus a lot on repository-specific searches and repository-specific analysis because we have so many different groups at NASA. Everybody has their own set of data that they're really looking at. They don't care about everybody else. They're very specific on certain areas that they're looking at. So what we did here's our lesson. And that lesson was written by this person, It occurred at a specific center. It's in this category. It's contained by this topic, and this topic has all these different terms in it. And this topic is also correlated to this other topic. Very simple. I wanted to keep it simple for the engineers, for them to be able to search through these things fairly quickly so they can pick these things out. So, and if you have a desire, this link here will actually get you to a little write-up I did on how I did that using all the tools that I'm mentioning here. And it will actually give you a location back to the GitHub account that has all the code in there and the data that's associated with that, so you can try to reproduce it. So here, after I imported into Neo4j, and this is where I give a shout out to Nicole White. I hope she's here. She really taught me a lot. There she is. She taught me a lot in looking at some of her videos and instructions on how to actually, when I first started learning Neo4j, how to import a CSV file into Neo4j. Utilizing a lot of her work, I was able to import that data set from that CSV file and created this quick little database here. So here you go. You've got this is a topic, fuel contamination, I believe it is, on topic on here. Not here. Let me see if I can read it even better. No, fuel valves, I think is what it's talking about there. And this valve, of course, has all these lessons that are in green and they're associated with these categories, and you can see what centers. So really quickly, you see there was a lot of a lot of lessons at KSC based on this particular area. So we can start seeing some patterns involved, and maybe we need to look from a management standpoint what's going on at KSC, that some of these issues are there. But that's just the beginning of what we can do with this. We can also look at individual topics and how they may be. We can look at the lessons within these topics. Again, here are the topics. The lessons are associated with these categories. This topic associated with this category that has all these lessons. And again, we can go from this same topic going out to this category and has all these lessons. So again, as an engineer, I have to be able to jump from one part of my system or subsystem to another. I can see the connections between my subsystems. As a project manager, I have to understand my entire system. I may have an individual working on the battery subsystem and another one working on the fuel tank subsystem and another one working on the lighting subsystem. And they all live in their own little world and usually don't talk to each other too much except in team meetings. The manager has to be able to look through all of this and be able to find that information, find out what's going on in each of those areas. So in order to do that, I had to try to come up with an application that would actually be useful to my end users so they could quickly jump through that. So when I first started using Neo4j, and this was done probably 2 years ago, 2.5, maybe 3 years ago, started reading a lot of different books, and there was a lot of different applications on there. And there's a lot of good visualization applications for Neo4j, and most of those guys are here. For this project, I selected on Curious. So here again, it's very quickly tied to Neo4j. I was very easily and quickly able to pull up a lesson. So in this real short example of what I'm looking at here, I have this lesson here. Fuel and oxidizer storage tank relief valves. So the engineer was looking for this particular type of lesson on oxidizing our tanks, fuel tanks, and any kind of issues with that. All the information for that particular lesson's over here, the title, the lesson itself, and even a link back to the original document in the database if they wanted to see all the other information that went with that. So real quickly, they were able to at least start with that. But from there, just by clicking on that, you're able to start seeing a little bit more information. So now I know that this lesson is in this topic on fuel, water, and valves, about fuel valves and water valves. Okay, that's what I'm looking at. I'm looking for valves here. So okay, it associated correctly. It occurred at KSC. It was written by a gentleman named David Pennington, and in this particular case, it was in this category was NA. They didn't actually assign a category to it. But we could start seeing how we might be able to jump from one area to another very quickly, utilizing this framework of knowledge architecture. Again, combining knowledge management, informatics, and now data science and data-driven visualization to be able to show and search through our information a lot faster and a lot quicker. So let's expand this a little bit now. We still got the same topic here. The same lesson associated with this topic. So I know that topic is what I'm interested in. I click on that, and now I pop up, in this particular case, another 10 lessons that are associated with that topic. So real quickly, imagine using the same keyword into your standard keyword-based search. You're going to get a list of documents. And you may have 2, 3, 4, 100 pages of this list. You're going to have to read each and every one just to figure out in your brain whether they're connected to each other. Here, visually, I can see that all these documents are connected to each other. And I can go to them a lot quicker and a lot faster and read through some of these right on the page here before I even want to go back and actually download the information, all the information on that particular lesson. Okay? So the next step of what we can do, let's say I want to look at the topic itself. I want to look at a topic in this particular case. This is on tank contamination and valve contamination. This particular topic in green right here. So if I open that up and I double click on it, it gives me two categories. Cryogenics on one side, and then the lessons that are associated here. These lessons here are associated with this topic of valve contaminations, and they're all very similar to that. But as an engineer, let's say I'm really interested in how, not only in the valve contaminations, but how it affects my subsystem on cryogenics. So now that I know it's in this category of cryogenics, I can click on that and see all the other lessons that are in cryogenics. Again, jumping from one step to the other, a lot faster, a lot quicker, being able to get that information to my end users in a more timely manner. And all of this was done, I tell you, with the information I had here in this particular case, and with Cypher and all the things I was able to use, it took me less than 2 or 3 days to get this thing up and running, at least to a point to where they can utilize it before we started fine-tuning it and started expanding upon it. Pardon me? So the question was, if I'm using this, was this a combination of Mongo and Neo4j? In this particular stage, it's still Neo4j as the back end only, and with Lincurious as the visualization aspect for my end users. Here is where I really got a, I don't want to say it was chilled or anything, but it really kind of validated why I thought this was such a good technique to use, and it really helped me to sell it to management when I started talking about this particular scenario, this use case here. So again, over here, valve contaminations, tank contaminations. I'm sorry, let me go back. I ran a quick Cypher query and looked at all of the topics that were correlated to each other with a correlation value of 0.4 or higher. Okay. Yes, that may sound like a lower R squared than you really want, but if you think about it, the higher it is, that document, because it's based on the document probability, the probability of that document in a particular topic. If it was any higher, it probably would have been in that topic to begin with, so it's no way for them to get too high of a correlation between these. So valve contamination. So it's correlated to another topic, which, and the titles here, the labels here, are the top 3 words that are associated to that topic by frequency. Okay? That's how I labeled them. So this is damaged air pump. Okay, so a damaged air pump, I can see how that may be correlated to a valve tank or contamination of a valve tank. You've got a damage to your air pump, there may be some issues. Okay, I can understand that. That works. But it's also correlated to fuel-water valve or water valves or fuel valves. Yes, okay, I can see how that works because you've got, again, we're talking about valves. They've got the same word in there. In this topic over here is the first word. And this one over here is the third word. So, I can see how there may be some correlations or some documents in there that may relate to what I'm looking for on tank contaminations or valve contaminations. But then I get to the last one. Fire hazard batteries. We're talking about battery failures, battery issues that may have caused fire hazards through my lessons, within my project, within my systems. Wasn't sure how does that really correlate back to valve contaminations or tank contaminations. So I started reading through some of these documents, all of in here. Started reading through some of the lessons. What I found was that we had issues several years ago with lithium batteries that were leaking, that were causing issues, that were close enough to valves that started to damage them. Some of the acid leaked into tanks, having issues with that. So those are the reasons that was correlated back to the valve contaminant, because things that we were doing in our battery system were causing issues to our valve systems. We wouldn't have been able to find that through a simple list search. But here, really quickly, with one quick Cypher query, I saw the connections, able to jump to those lessons really quickly to understand why something that doesn't seem to relate at all was actually a problem for some of my engineers. And remember, I told you my engineers sometimes don't talk to each other. They're in their own focused little world. They're doing their job. They're getting their things done. And unfortunately, we get to the point to where we get, our horse blinders on and we're just focused. We don't see what else is going on. This allows us to see what else is going on as we go through that. So there's a lot of good information here, being able to go through and run through our lessons to be able to pull that up. Now, yes, our next step is now we're working trying to get this into MongoDB so where we can have a user interface where users can input input the lesson directly into the database through Mongo. Then we'll run the text analysis in the middle of that to try to get back into a particular topic or do some, we're looking at other things such as text reuse, similarity of text, whether we've got different documents that may be similar, but they're so far apart we never would have caught them or looked at them, or even maybe paragraphs or sentences within those lessons that may be similar that we want to be able to try to connect somehow. We're also looking at sentiment. We've got a project going on right now where we're looking at the comments that the astronauts have made over the last 15 years with all our expeditions up at the International Space Station. We have a database of about 90,000 comments, when they come down. It may not sound like a lot, but over the years, that's what they're talking about as far as issues that may have happened on the International Space Station. What went right, what went wrong, what they liked, what they didn't like, what was wrong with and you'll be surprised, we get a lot of talks about the food, about the working out. So it was really difficult for a person to go through all these comments to find what are the trends. So we were working with them on looking at sentiment analysis, first off, on the comments, so we could just say which were they saying something bad about what was happening, which was something they were saying good. You'll be glad to know, I guess, that most of the comments are good, but I think part of that is because of the politically correctness of the astronauts. They don't want to say anything too bad because they want to go back up into space again. So that was an issue. There's a bias that's there. But we're able to look at all these texts and all these words that are in here and able to really try to get some meaning out of everything that's been said. And it's the graph databases, it's the data science, it's the knowledge management piece of it all combined together that allows us to do that. I do not believe in all of my years that I've worked, and I was primarily an IT guy for 20, 25 years, and in my own little world as an IT guy, and I realized later on that you've got to have all three of those things together and really to be able to make good business decisions as you go forward. It's really difficult if you don't have that because you're going to miss communications. Many of you guys might remember we had an issue several years ago now between one group doing something in feet and inches and another group doing things in meters and ended up, again, miscommunication because we don't talk to each other. We need to be able to do that, and that's part of where knowledge architecture comes into play. So let's think about what all you could accomplish as you go through all this. When you start looking at what kind of documents you have, how you're able to transmit those or transform those into actionable knowledge for your end users. You can improve your decision making. Of course, you can leverage your lessons from the past. We tend to do this all the time. We make the same mistakes over and over and over again. The number one lessons learned that I get in all of the lessons learned database is that we're constantly looking at how to redo our lessons learned database. But that we don't learn. We just don't read it, that we're having issues, so we need to figure out better ways of doing that. And of course, the learning curve. Part of knowledge management is to be able to take that know what into know how for the end user, to be able to make sure that the next generation that's up and coming gets the experience that I have, and I'm able to actually transmit it to them so they're able to use it. So things like this allow us to be able to get that information to them a lot quicker and a lot easier. And we can enhance the extension of our existing content in our document management systems. We need to increase our metadata within our information to be able to do more analysis on top of that. So the more metadata we have, I think the better off we'll be. So here's my contact information. I'm on all the different social media sites. Love to connect with anybody that's out there, anybody that wants any kind of information, wants to chat, wants to talk. Feel free to reach out. We can go through, talk about analysis, talk about space, talk about whatever you want to talk about. So I'll leave it at that point. I'll leave it up for questions. Yes, ma'am. These slides, the question was if the slides will be available. Yes, the slides will be available. Got a question back here? So recreating the graph based on the topics, is that the? Yes, generally, of course, you know that with latent data clay allocation, it's all a probabilistic analysis. So you can definitely come up with different categories of different topics. One of the first things I learned early on was to make sure I used the same seed number each and every time. I did that. I went through that for a little while there, going, why am I getting different topics each time? So that was my learning curve there. So yeah, using the same seed, being able to look back, trying to train your model to be able to pick up what the common topic should be with these, and then adding those into that. It's very easy to add the nodes back into Neo4j. So as long as you set up your analysis correctly, there should not be an issue with you being able to put the new lessons into the correct categories and topics. Yes. So the question is, how did I know that there was 27 topics in the learning data clay allocation analysis? Actually, in the analysis, you have to know what the topics are beforehand. So there are various methods. In this particular case, I'm trying to remember I use harmonic averaging on this to try to figure out what the best number of topics is. So really what I did is I ran latent data clay allocation on the group from using one topic to 50 topics to try to find out which was the best one, and looking at the harmonic mean on that, I was able to find out where the best quantity for my K value, my topic value should be. So as part of the pre-analysis you have to do to try to figure that out. You need to know that beforehand. So, yes, sir. The total data size of this particular data set? So the question is, what's the total data size of this data set? Here was only 2,031 different lessons. But if I'd apply that, because that's our public set. If I look at our private set, we probably have in the order of 150 to 170,000 different lessons that are out there if I look at all of our lessons learned databases. And that's the other thing. We have multiple lessons learned databases. They're not connected. They're siloed. Each group has their own lessons learned database. The average size of a lesson, again, we're talking, it really depends on who writes them. Some people can write a book, and other people just look at some very concise information. So I would say it's going to be a guess. You're looking at maybe 1 to 2 pages worth of information per lesson. This question right here first.
There's an excellent given that NASA is publicly funded, how much of your code for this is open source, or do you plan to open source some of this, or some of the data sets?
The code itself is going to be totally open source, and I've got that code on GitHub. The data, it just depends on whether it has been classified as sensitive or not. This is why I used, in these talks, I used a public set of lessons learned to be able to, so you guys can be able to replicate that information based on the code. But we're constantly trying to open up our transparency and open data with what we have, but it's not always easy because a lot of the information we have is, for example, maybe on our new rocket, the Orion, we can't necessarily let that out just yet. So once it becomes publicly available, I'll do it. But everything that I work on, I try to make sure I use publicly available data sets that could be replicated out there. That's another question? Yes, sir. One more time. The question is, anybody proactively looking at these lessons learned to try to prevent? Yes, I mean that's the general mindset of most project managers and project engineers, to be able to look at lessons learned. That's theory. In reality, because we make it so difficult for them to find the lessons, to actually use them, more often than not, they may do a cursory look, but not really do it as in-depth a search, because it'll take them too much time to do it. It's much easier for them to go out and do an experimental development and just make the error all over again and find out. It'll take them less time to do that than to go out and try to find the information out of that database. Yeah, you can say it that way. Yeah. Yes, sir. Yes, there are multiple levels of privacy because since NASA is an organization that works with international partners, we have data that only U.S. citizens can see, and we have data that anybody that's associated with NASA can see, and then we have data that everybody can see plus foreign nationals. So we do have different layers of data that's there, and then of course we have our public data that's just out there for everybody. So even within our private data, there's even different layers inside of that. Yes. The Roswell data? See, that's one of those things. If I tell you, I'm going to have to, No, I mean, I'm sure we could figure something out. Yeah, we've got somebody that can do that for you. Anybody else? Any other questions? Yes, sir. So the question is, do I see a role for virtual reality in some of these situations? The geek in me says yes. I really think that there are some possibilities, where I could see something like Iron Man going through and doing all of that. And I think, and we're getting there. We've got actually a really good group that's doing VR technology at Johnson Space Center. And I think somewhere along the line, we're going to make that connection. I just don't think it's going to happen in the next several years. Not for this type of information. More for engineering type of information. I think that's happening now where we're looking at parts, being able to simulate the parts and trying to put them together. Maybe so for system modeling type, yes. But for something like this where I'm looking at unstructured data, not just yet. Question all the way in the back? How deeply do I analyze the actual lesson learned content? Well, I try to I've applied very different types of models. So, of course, you got the latent Dirichlet allocation. I've looked at latent semantic analysis. And I started with the most basic topic modeling algorithm available. So I'm still looking at some of the new research articles that have come out for probabilistic LDA, for dynamic LDA. So I'm looking at different types of analysis, but I'm also looking at some sentiment analysis, similarity, maybe a word to vector type analysis. So there are many different things we're looking at. So we're constantly looking at ways to analyze the data to make it more useful. The question how deep, I'll go as far as the technology will let me go. So I guess it's the best answer I can give you right now, because I don't know it all. So if you got any suggestions, I'd be more than happy to try them out, definitely. Anything else?
Have you tied any of this content back to, the engineers that are reporting stuff? So, trying to kind of mine that data, like what kind of engineer reports certain kinds of problems and stuff like that? Or do more senior engineers have certain kind of problems whereas other junior ones don't? Something like that?
So the question is, have I tried tying this back to the person that's actually reported the lesson? Does like a senior engineer report different types of lessons than a junior engineer or type? I have not, but you've given me a great idea. I can see where that's a good possibility to look at to try to see whether, is there any complacency that happens as an engineer gets older, that they may not start to write a lesson, or maybe do they write too many lessons up front, and then we need to teach our engineers something else, or so yeah, there are some ways of doing it, but unfortunately, I don't think I have the metadata available for that just yet. So it gives me an idea of different types, and this is where I get it, where I say metadata is important. These are things like this that's brought up in these type of conversations that I need to go back and add to my information to be able to try to do this type of analysis. Because you can't, if you don't have the metadata on it, you can't do the analysis. It's difficult. But thank you. That's a good thought. Anything else? If not, I really appreciate being here. I thank you for your time, and I look forward to talking to you guys.